Morning. Today we're going to evaluate a one-sided limit and look at it and talk about what it means. So we have the limit as x approaches positive 2 from the left of x minus 4 over x squared minus x minus 2. So we look at the form of the limit. And we could factor the denominator, but we could look at the form first and see if we even need to. Sometimes it's easier, but anyway, the form of the limit as x approaches positive 2 from the left, 2 minus 4 is negative 2. 2 squared, the denominator is 2 squared is 4, minus 2 is 2, minus 2 is 0. So we have the form negative 2 over 0, which tells us that this limit does not exist. But we want to describe this limit a little bit better. We want to know how it doesn't exist and what way is it going. So in order to do that, it helps to go ahead and factor. You can analyze it right from here, but it helps a little bit if you'll go ahead and factor the denominator. So before I actually take the limit, and we'll go back to this form, say the limit as x approaches 2 from the left of x minus 4 divided by, the denominator factors into x minus 2 times x plus 1, correct? X times x is x squared, negative x, negative 2. Yep, that's it. So we can clearly see that we haven't changed anything. The denominator is still 0, but now it makes it a little easier to see what would the sign be of that denominator, because it's really not 0. We're just really close to 2. At 2, the denominator is 0, but really close to 2, just to the right of positive 2, it's a signed value. So, positive or negative. So let's see what it is. So to the left of positive 2, 2 minus 2, like positive 1.9 minus 2 is a negative number. To the left of positive 2, like positive 1.9 plus 1 is a positive number. So we have a negative times a positive. So the denominator would be a negative number. So we say that, that's just a little common notation. We say that 0 would be a negative. And sometimes we put a little circle around it to say that we're not, just to kind of say what we're saying there, because 0 is technically not signed. But anyway, we have the form of negative 2 over 0, but it's a negative number that's really close to 0, so a negative over a negative makes a positive number. And we know that the form big over small implies infinity of some sort. A number over 0, in other words, implies infinity. So we know that it's an infinite limit, but at the same time, we have a negative number and a negative number. So therefore, we can say that the limit as x approaches 2 from the left of x minus 4 over x squared minus x minus 2 is positive infinity. And what that insinuates is that at this function, whatever it looks like, at positive 2, as x approaches the x value positive 2, as the function approaches that, the y values approach positive infinity, and we have a vertical asymptote.